Okay, all right, well, let's get started then. Um, okay, thank you everybody for coming today to join this session. This is building native apps and web services with Swift. Today we're going to talk about how to build a native macOS app with Swift UI and a server-side app with Vapor, which is a web framework written in Swift. About me, my name's Steve. Unlike everybody that I work with and everybody here, I did not graduate from FIU. I got my bachelor's in information systems from MDC. Shout out to Lawrence Meyer and David Freer. I'm currently a software developer at Addigy, but previously I worked at a company called Code Academy. And I really like writing Swift apps. So that's why I'm here today. A couple things that you're gonna need to follow along. Obviously, this is a Swift-based workshop or talk, so you're gonna need a Mac to run that on. I wouldn't recommend the compilers that run on Linux. It'd probably be better to just have Xcode and everything built in there. We're doing this in Swift UI, so that's why OS X Catalina is a requirement. And Xcode 11 is probably the earliest version of Xcode that brings Swift UI, which also brings the developer tools, so stuff like Git and other things that you might need. You'll also need to install Vapor. Here is the link to do so. And Homebrew. Homebrew, it might come by default now with some Macs, but I'm not sure. But just in case, check if you have Brew. If not, go ahead and install it. Okay, so what are we building today? We're going to be building a native macOS app that lets us install other apps. We're going to call it Appigy. It's fitting. Appigy is going to be written in Swift UI. It's going to leverage network requests to basically fetch data from the server and child processes to perform the installations. The Appigy API, so the backend, will be written in Vapor and is going to use a simple SQLite database for storage. If any of you guys are familiar with MySQL or Postgres and you kind of have like those databases running on a local server already, by all means, feel free. Okay. Additionally, I do have a couple repos set up, so both Appigy and the Appigy API. So just go to github.com/SteveToro/Appigy or /Appigy API. And both of these have ShellHacks branches where you guys can just clone that and immediately have all of the images and any kind of like, helper functions or any additional setup that I will go through today. So anyway, go ahead and create a new macOS project. Choose Swift UI for the interface and app delegate for the lifecycle. Do not choose Swift UI for the lifecycle because that will require not just Catalina, but actually Big Sur, the latest version of macOS. So app delegate is what we want for the lifecycle and Swift UI for the interface. Leave core data and include tests unchecked because we're not going to be doing any TDD or any kind of like local databases on the client side. Our database is just going to be on the server side. And navigate to signing in capabilities and remove the app sandbox. Then go into the info plist and add transport security settings property. So I'll demonstrate what this means. So here is a kind of like your bare bones project. Like once you've hit create new project and you selected Swift UI, you're going to want to click on the project name, go to signing in capabilities, and here where it says app sandbox, you're going to want to click this X. The reason being is that we're going to be running some child processes that are going to use your file system pretty extensively. That's the only way that we're going to be able to install any applications. So we can't be running in the sandbox to do those things. And as far as the app transport security, it's a matter of clicking here, app transport security settings, pulling down the little drop down, hitting this and allow arbitrary loads and setting this to yes. So that's what I'm referring to in these last two steps. What this is accomplishing, I already mentioned that the app sandbox is so that we can install the applications, make full use of our file system. But what we need the app transport security settings property is so that it's because we're not going to be actually using an HTTPS server. We're going to be using a local host server. So we're not actually going to deploy our backend anywhere. We're not going to make any request to like any external server. We're just gonna be running it locally. So to do that, we need to have this active in our plist so we can hit localhost. And okay, let's get started. So Swift UI, right? So our app requires 3 basic views, right? So if we're looking here at what we're going to build, it's not the prettiest app. It's going to demonstrate like the basic concepts of Swift UI, right? So we can think of this UI as having 3 basic views. We can have a single app item, which is this thing that we're seeing here, which is the image, 1Password security, Brave browser, so on. Like these individual units are one item. We can think of the whole list on the left side as yet another view, another item. Well, let's call it a list. And you can think of this as just one view we can just call it a detail view. So we're gonna go ahead and start implementing these from the smallest views to the largest. So we're gonna start from the app item. The app item, we're gonna pass it to the app list. And then finally, we're gonna leave the app detail for last. Okay, so I'm gonna jump into the commit where I did this. Before I do so, let me just go through these, let me go through some of the code that I prepared here. If you go to, if you clone from the ShellHacks branch on GitHub, you're gonna have all of this code included automatically. Basically, what I've done is I've created a utils folder. We have a network file that it's basically just going to make a request to an endpoint that will return some app data. We have our model, which is basically just the type that we're using. If you've written Java or C++ or anything like that, this probably seems a little bit familiar. It's just a type with some properties, and that's going to be the most of our data. I've declared this global variable Addigy apps. It's just a bit of mock data. It's what we're going to use for the time being until we move over to the server. And the process, this is how we're going to actually install the apps. So I mentioned that you need to install Homebrew. It's because we're going to launch a brew process and pass it the following arguments: cask, install, and the formula. What is the formula? The formula is the command that Homebrew recognizes the app as. So if you wanted to install, let's say, Tor browser or something like that, you could go into your terminal. I can't open my terminal. What's going on? You can go into your terminal and run something like brewcask install Tor browser. So even though you might know the app as Tor, that Tor browser part, that's the actual formula. And you can find similar things on just Google Homebrew, and you can look up Homebrew formulae, see all the casks, and these are basically all the graphical apps that you can download through here. So you have 1Pass, Adobe stuff. Like you have a lot of cool things that you can download through Homebrew. I'd highly recommend doing so. Anyway, yeah, these are the main helpers, right? So we have an install function that's going to do this. One thing I should say, so once you install Homebrew, you should definitely go to your terminal and run the following command. Just run which brew, and this whole string is what you're going to need to put into that file if it's different from what I have, right? So just make sure that what you have is what's in here. And otherwise, we won't be able to launch that process. And yeah, so we're gonna have a helper that gets the apps, a helper that gets app images. We're gonna get images from the server. We're not gonna store them locally. And that's probably it for now. The app delegate, for those that don't know, that's kind of like the entry point to your application. So before you have, even any of these views that we've talked about before, before you even have the window that you put that view into, you have the app delegate, and this kind of manages some of the lifecycle methods for your application. So different points, like when the application just finished launching, when the application is going to close, when the application is going to handle some URL, any number of things like that. So yeah, just wanted to give you a heads up on these helpers real quick. So moving on, we're going to create these 3 views. What does that look like? What I've done is I created a views folder, or group, I should say, and I haven't changed anything I haven't done anything to them. This is just what you get when you hit File, New, File, and Swift UI view. So app item is just text that says hello world, app list, hello world, app detail, hello world. And we're going to start with app item. We're going to start implementing that now. So what does the app item look like? Going back to that slide, you could say that the app item is basically just a row. It's like a horizontal structure. First you have an image, and then you have a column, right? So you can say it's a row with 2 items. The first one is an image, and the second one is a column. The column has 2 text items on top of each other. So that's kind of the gist of how you think about UI in Swift UI. You kind of like break down your UI into, okay, well, do I want to align this horizontally? Do I want to align this vertically? Do I want to add some spaces between them, and then like kind of adjust the padding or any kind of like minor details? But basically, you first break it down into like, okay, does this fit in a column, or does it fit into a row? And does that column or row have some other column or row inside of it? So we have some specific views for handling exactly that. So like I said, we have a row, and that's kind of like the main structure, right? So in Swift UI, we have a view called HStack. So this is me symbolizing, or me telling Swift UI, hey, give me a row. And the first thing I'm going to do is I'm going to create the image. I'm using the image app store. This isn't a random image. This is something that I dropped into the assets catalog. Again, if you clone from the ShellHacks branch from that repo, github.com/steve-toro/Addigy, you're going to have this image automatically. So you don't have to go scavenging for images or anything like that for this tutorial. And we're just going to call resizable on it. So we don't want the original size of the image. We just want this 40 by 40 frame, and we want it to resize to fit that frame as good as possible. And the item right after that image is the column that we mentioned. So here's where we have a VStack. And we want it leading, so we want everything kind of just flush to the left as much as possible. Reason being is that we want the text to align. So we don't want this to be centered. We just want it to be flush on the leading side of the view. And we're going to add some text, right? We have 2 text items inside that column. So one is the app name. The other is text, the app category. And I added some modifiers to kind of like change the font weight a little bit slightly. And some spacers to just kind of like push the app to the left a little bit to just make sure that everything is aligned as much as possible. So on the outside of this HStack, which is kind of like the overall view, I specified a width of 150 by 80 in height. And that's just kind of, if you're wondering how I got that, it's really just a little bit of trial and error and experimentation. It's nothing in particular that I had in mind. But so if you want to like see your progress as you're working, you can hit the preview over here, and you see, okay, that basically looks like the boxes that we have in that slide. We're using the default App Store image. That's what we have right now. We're going to get our actual images from elsewhere, but we have some mock data here, and that's good. This preview is being supplied by this struct down here. So it's the same app item, but it's conforming to preview provider, so it can be displayed here. And I'm just providing it the app that it needs for this information. So if you notice here at the top of this struct, I should have mentioned that at first, this view is going to have a reference to an app. So every one of those rows that you saw in here, each one of these rows is going to have its own app, and that's how it's going to know how to build its own view. And here, for the sake of previewing, we can provide it, the first app, the second one, and you see that it's changing immediately. So we actually don't even need to run our what's it called, our emulator or anything. We're just seeing the preview right there with some mock data. So anyway, that's it for the app item. Next, it's going to be the app list, which is actually going to be a lot simpler. Actually, the app item is in some ways the most difficult view here because it's a row with a column inside of it. So the rest of these are just going to be either rows or columns. So let's see, app list. So like the app item that receives a single app, the app list is going to have the list of apps, which right now I'm pointing to that helper that I defined over here in model, right? So I'm just saying, hey, app list, use these apps and render the following. Just render a list of these apps using the ID property to keep track of them. And for each app, render an app item and assign each of these app items the current app. Again, we can, so here, in the preview provider, we can see the app list. We can see like what it's going to render like. We're just passing it that same global variable that we have over here. Again, this is just mock data. This is just to make our UI development a little bit smoother. But here we go. That's basically what the app's going to look like. Eventually, something is going to come up over here, but this is basically what we want to see. And that's it for app list. Told you it was easier than the app item. Let's see the app detail view. So the app detail view is basically just one column, right? So we have a series of view items, of view elements, kind of in series from top to bottom, right? So we have an image, the name of the app below that, the category, some kind of a description, and then a button. So there's really nothing else to do here except just wrap this view in a VStack and apply those same view objects that we're getting familiar with, right? So the first one is an image that works the same way as before. So a resizable image with the following frame. So we're going to make it a little bit bigger than the icon for kind of obvious reasons, right? So we have a 40 by 40 icon here, but we want something bigger on the detail screen. And the name of the app, the name of the category, or I'm sorry, the name of the app, the category of the app, the description of the app. I'm putting a little bit of padding around the description just so that we kind of like have like a little bit of space here, so it's not just a cluttered wall of text. And a button that for now is just going to say install. And when you click on it, it's just going to print something. And again, I'm just giving this this frame over here a width of 400 and a max resize as much as possible. And the preview is just getting that same global again. So we can again hit our resume and see what that screen is going to look like. And that's about right on the money. That's about like what we're trying to see. And we can switch through different elements of the mock data. Okay. So at this point, we've got these three different views. We kind of have the building blocks for our UI, but we haven't actually done anything to render it, right? So we still have like this content view that's being rendered by the app delegate. and it still says hello world. So if we run this, it's probably still not going to do anything. It just says hello world. So what we want to do now is hook up the actual app list view to this content view. We're going to replace this text view with the app list. It's a little bit of a trivial change, but still easier to just go through the commits and to live code it. But anyway, so now the content view has the app list. It's the same frame. Nothing else has changed here. So if we run this, now we have an app window that's displaying the data that we want to see. So again, no image. We just have some mock data. But we would expect that if we click on any of these, that something would show up here. So we're missing that detail view. That detail view is not hooked up just yet. And so the reason is that we haven't actually added any navigation to this app. And we're going to do so now. So we're going to add a navigation view to the app list, and that's going to essentially navigate us to the app detail view. So all we've done is we've wrapped a navigation view around the list that we had. So the list has remained the same, but we wrapped the navigation view around it, and then we've wrapped the app item view inside a navigation link. And we specified that the destination is app detail, and we passed the current app. So all we're doing here is saying, okay, well, we have this list of apps. Each one of these app items is in charge of a single app. And if I click on any one of these, I want to pass that app to the app details view and display it. So let's see what that looks like. All right, so one password. We've got a little bit of navigation in here. We're switching between different apps, and the install button isn't actually really doing anything except just printing out to the console. So install Dropbox, install Discord. So I think that's about it for now. I think at this point we're ready to to move to the server side and start giving this some data. All right, so we're going to move on to the API now. Make sure that you are going to github.com/steve-toro/Addigy API. You can just clone that repo and switch over to the ShellHacks branch, and you'll get a good starting point with a few images and other assets and a little bit of a setup boilerplate gotten out of the way. But otherwise, what you're going to want to do is you're going to want to have Vapor installed. You're going to want to go to your terminal, run the command Vapor new Addigy API, or whatever you want to name your API. It's then going to ask you if you want to use Fluent. Go ahead and type Y and hit enter. That means yes, we do want to use Fluent. And when asked which database to use, pick SQLite or something else. Your mileage may vary. I'm just choosing SQLite because I don't have to run any local servers. It's just a file-based database, very simple, and it kind of like proves the concept. Fluent is the ORM for this web framework, and ORM is an object relational mapper. What that means is it lets you treat your data layer like any other object in your app, which is kind of how you want to think about your data, right? You don't want to like sit, kind of like go into the SQL or Mongo queries if you're using that, like, just use the domain-specific language. Next, once you've run that command, Vapor new Addigy API, you're going to run cd Addigy API. So basically, you're going to go into your project folder. And you're going to run Vapor Xcode to open your Vapor project in Xcode. Click Apigee API at the top near the run button, and you're going to select the working directory to be the one that contains package.swift. So to demonstrate what that means, you're going to want to go over here into Apigee API. You're going to want to click on the name of your app. You're going to want to hit Edit Scheme, go to Run, make sure that this working directory is checked, and make sure that you're using just the directory to your file, to your project. So here I just have it in my desktop, and that's the root of the project, and that's where the package.swift is. The reason why that's important is because we're going to store some files here, db.sqlite in particular, and we don't want Xcode looking for this file anywhere else. We just want it to look for it right here. We don't want to have that file elsewhere. And yeah, just keep your terminal open because you're going to need it again soon. So this is what the Apigee API looks like after just a fresh Vapor command. Some of you might be recognizing that we have kind of an MVC pattern here. So we have models, which, what does that mean? We have a to-do. The to-do conforms to model and content. And it basically just seems to be, the fields that are in our database, and probably the fields that we're going to work with in our business logic layer. Migrations, what's in here? It looks like we're creating a schema. So maybe we're creating a to-dos table, and we're saying that that table needs to have a title field of type string, and that's a required field. And then, once you've specified these fields, you just create it. So next we have like the controller. And again, it's giving you the bare bones scaffold for having like a little bit of an API, right? So this controller has an index function that just returns all of the to-dos. It gives you a create function that lets you create a to-do, and a function that lets you delete those to-dos. So we're not going to be creating any apps or deleting any of them. We're just going to populate our database and just return it from this API, from this server. And so we're going to be able to just erase all of this, these two functions. And then up here where we're registering the routes for the app, what we're saying here is, okay, so you want to run this on localhost. So this grouped function is basically just setting localhost /todos. And if you make a GET request to that URL, you'll use the index function. If you make a POST request to it, you'll use the create function that we just deleted. And if you delete, if you pass an ID, so a specific identifier for a to-do, it'll use that delete function. But again, we don't need this stuff. We're just going to populate our database and just return that stuff. But anyway, we kind of got a lot of stuff for free here. Yeah, it's to-dos, and that seems pretty trivial. But it's also pretty trivial to just kind of like rewrite these files into the model that our app needs, right? So, instead of to-dos, we could just do /apps. Over here, instead of just title, we're going to use name, and we're going to use category and brew formula and like a few different things. And here we're just basically redefining the same struct that we did back in the Apigee app. It's basically this, but with a few more tags to indicate that this is actually being used by a database. And in the configuration file, we're basically just saying, hey, we want to use DB-SQLite and run this migration. So this migration is what's going to create the to-do table. So we're going to want to create an app table. So we're just going to rename this, and we're going to migrate all of this stuff over to something that we can use. And then as far as routes, we get 2 for free. We get one that just says it works. If you just go to localhost 8080, it'll just return it works. If you go to localhost /hello, it'll say hello world. And then finally, it'll register the to-do controller, which again, that's just registering the /todos endpoint. So this is the stuff that we're going to rewrite, and we're going to appropriate it to our app's needs. And I'm going to skip forward to it a little bit because it's just a little bit of a deleting and rewriting. Let's see there. This is anything here. Okay, so you'll see that now I've changed the controllers, right? So like now instead of the to-do controller, we have Addigy API controller, and it's not pointing to to-dos anymore, it's pointing to apps. The index method is now using Addigy app, which is the model that I've defined down here, and just returning a future of that type, so an array of apps. That model, what does that model look like? You know, like we discussed before, we just need to change the fields on this class, and it's ready for us to use. So Vapor kind of gave us a lot. It kind of gave us a whole template for us to adopt to however we saw fit. We could completely extend this over and over again as we added more tables to our app logic. And the init method, you know, so when you create one of these Addigy apps, you know, you just provide the name, the brew formula, which you can get from the brew website, a description, which I got from Wikipedia personally, and the category, which I just made up, and the image name, which again, I just made up, but I'm going to add those images to this repo shortly. And then anyway, so the migrations, what do they look like now? We're creating a schema called Addigy apps. So we're creating a table called Addigy apps. With the following fields: name, brew formula, description, category, image name. We're saying that they're all required and they're all strings. So this is a pretty simple table. It's a pretty simple schema, but it's sufficient to prove a point. One thing that I have added that we didn't get for free is this second migration over here called seed Addigy app. And you'll notice that it conforms to the same protocol. Like it is still a migration. And here, I've basically passed the same hard-coded data that I had in my model over here. It's basically the same, except I didn't specify an ID here, or there rather, because it happens automatically by the database. So the data that I'm hard-coding and keeping in memory in the Addigy app, I'm now just going to use to fill my database and just return that from my endpoint. So basically what's happening is, well, let me go to configure real quick. So configure, I've added the create Addigy app migration, and immediately after that, I've added the seed Addigy app migration. So what's happening is we're gonna run the migrations, and first we're gonna create a table. The table is gonna have these fields. But then I just want to fill it. I just want to put something in there so I can actually start using my API. And that's what I'm doing here. And routes, you know, I basically just replaced the to-do controller with the Addigy app controller. And that's basically it. So at this point, if I wanted to run my app, let me delete this database real quick. I'm going to run the app now. Yes, go ahead. It's running on localhost 8080. So it works. I'm getting a response from the main endpoint. I go to hello, it says hello world. But if I go to, not to-dos, to apps, it's going to say there was an error. And the reason being, there's no such table Addigy apps. Well, how could there be if I just deleted my my database, the db.sqlite file that you saw? So what I'm going to need to do is go into my project and actually tell Vapor to run those migrations. So desktop Addigy API, and that command just looks like this. vapor run migrate. Okay, so it's telling me that it's going to prepare the following migrations. So first it's going to create the Apigee app table, then it's going to seed it. That's exactly what we want. That makes sense. This is what we've been expecting. SQLite journal, not sure what that is. But we can run this app again, and we're probably going to see data unless this journal messed it up for some reason. So we're seeing data. So we're seeing data on a local web server. So the idea is if we wanted to deploy this to, say, Heroku or perhaps some service on AWS or Azure or what have you, then anyone could access this data in your database. And our app will as well. So one thing, right? So like this is just a JSON response. And we're just seeing text. We're not seeing any images. So where are those going to come from, right? You might say, hey, images, and then tor.png. And that's not found. Well, the reason is because I haven't added those images just yet. But there will be something else that we need to do before we can see those images. So what we need to do is add static file serving from the public folder. If you remember when I went into my configure file, we added the migrations here, we specified SQLite, but there's also this commented line of code that we didn't write. This came with the app, and it's saying uncomment to serve files from the public folder. App middleworld.use, public directory, app directory.public directory. So basically, if we uncomment this, we're going to be able to add a public directory and just serve files from there. And that's where we're going to have our images. But you can also have other things. You can have HTML files, JavaScript files, any kind of static asset. So in this sense, your Vapor API can be used to serve an entire single page application, whether in React or Vue or whatever you prefer. This will just be an API. It will just be a backend for us because our client is an is a macOS app. So we don't need any HTML or anything like that. So I've checked out, and you see that now there's a new folder here called public. Inside of it, images. And in here, I've included these logos, right? So again, we're a little bit far into like maybe this app, but if you clone from the ShellHacks, you're going to have these assets already. You won't have this stuff right here if it's just leaving it as an exercise for you guys. But you're going to have these images, and I believe that the config will be taken care of as well already, so you're ready to start serving those assets. But anyway, let's run the app and let's see what's going on. Okay, so we've got the Tor image now. Let's say, WhatsApp. We've got the WhatsApp image and the Brave image. So we've got static file serving now. And this is what our Apigee app, the macOS app, is going to use to polish up its UI a little bit, to actually have some images. So our client actually can't really store all of these images. Like maybe you could cache them in some way or another, but usually you would get those images from somewhere else, and that's the purpose that our API is serving. Apps, we're still there. Cool. So going back to Apigee, the Swift UI app, we don't want to use our hard-coded data anymore. So we're going to make some changes to our views so that we're not using that global variable. We're still going to use it in the previews because we don't want our previews to depend on something that's coming from a server. We would ideally like to just, while we're testing, while we're previewing, while we're playing around with our UI to just have some mock data there to test with. And once we do this, we're going to start just hooking up our UI views to the helper functions that we talked about earlier. So the network helper functions such as get apps, which is just going to get that list of JSON, get app image, which is going to actually request the images that we saw as well, and the process function that's called install, which is actually going to do the installation. And we want to call these helpers as soon as these views appear. So our views are initially going to have no data, but they're going to make the request necessary to, or they're going to have a default value. So for example, the app list will have an empty array of apps, whereas the app item and the app detail will have a default image value. For example, the app store, that's something that we still have in the app and we can still continue to use. And then finally, we're going to hook up the install helper from the button handler that was in the app detail view. So the one that was just printing, oh, installing such and such, we're going to hook that up to the helper now. This is the API. So this is the stuff that we don't want to use anymore, except for our preview. All right, so what does that look like? So this commit is making a change to the app list, right? So the main view that just gets all the data and we figure out what to do from there. So before, my apps variable was Addigy apps, the global variable in here. Now I'm just declaring it as an empty array of type Addigy app. And then on appear, so this navigation view, as soon as this navigation view appears, I'm calling the function. So I'm calling get apps, and then on complete. So once the message is complete, it can either have some data or it can have an error. If there is an error, I just want to go ahead and print it. But otherwise, I want to update that apps variable, which is why I have this state modifier on it now. So before I didn't have this, but now that I actually want to modify it within the view, I need to make it a state, because all of these views, the philosophy behind Swift UI is that your views are just a function of state. So a view is just something that can be thrown out and recalculated if the state changes. So yeah, I have a list of apps. If it's originally empty, but then it adds something, we need a new view. We have a new state. So let's see what this looks like. All right. It looks the same, and it should, because we're using the same data. But now we're getting it from this API instead of that global variable. To prove it, let me stop this API. I want to restart the app. There's nothing here. So this app is now not dealing with any hard-coded data. It's literally just requesting a service the same way that you would request information from Twitter, from Instagram, from Spotify, from whatever API you prefer. So let me get this API running again. And now we're going to start fetching the images. So we're still using the default App Store image. We're going to get the images now from the API. And there's two places with images. So we have the app item and the app detail view. And we're going to follow the same strategy, except now we need, before we were just creating an image, we're declaring it right here in line with the H stack. Now we want to declare it as a state variable. So we want to use the App Store if we're not able to get the image. But if we are, then we want to replace that image. So to do that, we need to use that @state tag. And we're doing the same thing as before. So as soon as this H tag appears, we're going to call the get app image helper function. We're passing it the image name, which is just part of our app model, remember. Each app item is in charge of a single app, and that app has an image name property. So we're just passing that to this function and then saying, hey, if there's an error, just go ahead and return. However, if we have data, as in an image, that's what this function is returning, then we'll just reset that. And we're doing the same exact thing for the app detail view. So instead of doing the inline image declaration here, we're just referring to this state variable over here, which starts off with a default value of App Store. But once the view appears and it makes that request, it'll replace that. It'll replace that image. So let's run this now. And we've got some images. And if we click on anything, we've got another image. So fantastic, we're almost done with this app. The only thing that's missing is this install is still just printing out, installing 1Password or installing Dropbox or whatever. So we're going to hook up the last helper method that I provided. And we're going to make use of Homebrew. So that's happening in the app detail view. So that button that originally just said install and then print is now calling that install function, and it's passing the app brew formula. So the app brew formula is what tells Homebrew this is the app that you want to install. You can't just use the app name, you need the brew formula. If we go back to Homebrew, I think, I'm not sure if I pointed it out before or not, but so this column over here is the app name, but the formula might not be exactly like it. So for simple names like WhatsApp, yeah, it's probably what you think it is. But for 1Pass CLI, you know, you might be missing a hyphen, or there might be some other character that you're missing. So this is a good place to double check your assumptions. And they have a JSON API too, so you could possibly just use this directly. And the only thing is that they don't have images here, so whatever. But yeah, so now calling this function, let's see what's going to happen. So let's say Brave. Let's see, my applications are over here. So I'm going to try to install Brave. And all right, it's doing something. Okay, see, this is why we need to get out of that sandbox, because we're making use of a lot of the file system. And going back to Xcode, going back to our IDE, we see that there is actually some activity going on here once we click that install button, and we're seeing it's related to Homebrew, and you get the gist of it. It's installing something. Okay, Brave browser was successfully installed, and here it is now. So that's pretty dope. Let's see, let's install something else just for proof of concept. Let's say WhatsApp. No, let's say VLC. This is probably smaller. So VLC, so it's not in here, right? But we can just hit the install. You see that this is already going off again. And it might be more than a few seconds. 27, 64. All right, it's probably almost done. Let's wait for it. Oh man, still going, still doing some other stuff. I wonder if there was a smaller app I could have chosen. About WhatsApp. All right, so it's doing both right now. So let's see. Okay, WhatsApp showed up. So WhatsApp got first. I guess VLC is a lot bigger than I expected. But anyway, guys, that's it for the presentation. You know, we've covered kind of a lot. You know, we have a native Mac OS app that communicates with a server that communicates with a database, And that's a lot to do with just writing a single language, which is Swift. So if you guys want to connect, if you want to provide any feedback, feel free to email me, steve@stevetoro.com. Again, the GitHub has both of these repos, both of these projects. Make sure you're starting off from ShellHacks, or stay in the master branch and just revisit how the code is progressing if you want. And you guys feel like connecting on LinkedIn, here it is as well. So anyway, that's it for me. Do you guys have any questions? Is it possible to give you guys audio or anything, or should I just scroll through this? There you go, Kimley. The GitHub file doesn't look like mine. Elena, just make sure that you are using the ShellHacks branch. So if you go to github.com/stevetoro, you should be able to switch here, and that will be the starting point that includes all the stuff. Awesome. Thank you, Reddy. I'm glad you appreciated it. Yeah, basically, you can think of it that way. So I'm speaking to Alan. It's a UI wrapper for Homebrew. Yeah. So at Addigy, we have our own kind of a software catalog and mechanism for installing apps. But I thought, there's no reason to get super complicated when there's, just a utility that you can use directly. So I just kind of use that as the easiest way. But you don't have to think of it that way. It's really just to prove the concept of a native app, building the UI, getting data from somewhere else, and that's it. You could do whatever you want with that. No problem, Alan. Thank you for coming and watching. Thank you, Denai. Thank you for hooking it up at work, getting us all involved. And okay, if there's nothing else, just if you come up with anything afterwards, here's the contact information. Alternatively, I am in the UPE Discord if you guys want to hit me up. Make sure you're hitting up the account that has the image, the profile pic, because otherwise it might be a wrong account. And I think that's it. Thank you, guys.